Well, hello everybody, and welcome to another episode of Watch Tony Mess Up the Guitar Amplifier Project. No, actually, we've had some success and had a little bit of time to get back on this a little bit and figure it out. And of course, in our previous episode, we can remember that we totally screwed up by using the wrong output transformer. We have a power transformer that puts out too much voltage, and we had all kind of issues, but we got them all sorted out, and I got this thing working really well. Believe it or not, even though it only has 3 tubes if you count the rectifier and 2 tubes if you don't, this thing's putting out a pretty solid 16 to 18 watts, and for a single-ended amp, that's pretty considerable. This thing's running hot a little bit, but it is a KT88, and actually I have a KT100, which has even higher ratings on it. But the tube really doesn't seem to be heating up that much, and it sounds pretty good. So anyhow, let's go over some of the things that we figured out and how we ended up getting a final design on this amp. And then I'm going to really treat all you guys today, because I'm going to share with you some of my horrible, lousy guitar playing capabilities on a guitar that I built from scratch in my shop. It was one of my first guitars I ever built, and of course it's terrible, so everything's terrible. So if that sounds really exciting to you, then stay tuned, because you're in for a treat. Anyways, so we ended up with the final design. We have a 12AX7 driver and preamp tube. We have a KT88 output tube, and I'm using a 5U4, which is a pretty readily available, pretty common rectifier tube, full wave rectifier that you find in old TVs or whatever. So again, this is an old TV or old transformer out of something. I don't know. It's ancient. I've had it forever. And it puts out way too much voltage, and I had to mess around with that. But in spite of all that, this is a prototype, and it works really well. The schematic I'm going to give you, though, is a good one you could build. And if you buy a good set of transformers, I think you'll have really good results with this design. Now, a word of caution, anytime you mess around with the bias settings and everything of a design of an amplifier, there's always going to be people out there that are going to comment and say, oh, if this math formula and it's biased at this point and the key quiescent current and all that. We're not going to get into all that. Basically, the amp is designed to produce a certain sound when a guitar is played through it, and man, when you're designing a guitar amp, it's really not like designing an audio hi-fi amplifier. The frequency response, the distortion characteristics, all those things kind of have different rules for guitars than they do for hi-fi audio amps. So what may sound really good on your home stereo sounds lousy if you plug your guitar into it. And vice versa. I sure wouldn't want to plug my MP3 player into this, even though it would play and it would reproduce the sounds. It's not going to have a linear, flat response curve. I purposely did not use global feedback on this, okay? I want the amp to break up. I want it to distort. I want to be able to control that. So all those things come into play when you're designing a guitar amp. Most of you out there who are into guitars know this. Those of you who are just into building or hobbies, electronic hobbies, may not know that. So before we look at the underneath of this and get into the meat and potatoes, let's look at my scribbled down schematic. Okay, schematic time. So let's move this down here. Let's get you zoomed in a little bit. All right. Okay, here we go. Can you all see that? I'm going to try with the light and without and see what we get. No, that's pretty crappy. Let's go back to this. Let's stick with that. All right, so as you can see, it's a very simple circuit. Now, the first thing you'll notice is this transformer is 300, 0, 300. The one that I have in here right now is 400, 0, 400. It is way too high for a single-ended amplifier. It's way overkill. But again, when I started this project, I wanted to use as much salvaged parts as I could. Unfortunately, I didn't have a suitable output transformer, so I did have to break my rule a little bit and buy one of those. But with the exception of that, all these other parts are things I had around the house, around the shop, scrounged up and put together. Even the chassis, just a bent piece of aluminum, sheet aluminum I had, all handmade. As you can see, this is a very, very typical power supply. So you have your 5U4, full wave rectified, your 5-volt filament comes out, got a couple equalizing resistors, and because this exceeds 450 volts, I took 2 capacitors and put them in series and put some equalizing resistors in there, and that gives us, as you see, I have 2 47s, so I'm going to get, around 20-25 microfarads with these, okay? So it'll be like, if you want to get technical, it'll be 23.5, but it's going to be around 22 microfarads, which is just right for this little amp. Then I go through a 100 ohm resistor, and this is making up a pi network. We talked about those in other videos. And then I'm going to another set of capacitors, which are 100s at 450. So that gives me 50 microfarads right here, roughly. And another set of equalizing resistors. Then we go through another pi circuit. And if you notice, I put an asterisk there. The reason I put the asterisk there is this is the resistor you're going to use to adjust your voltages feeding your driver and preamp section here, okay? And you want this to be, when it's all said and done, you want these voltages here to be somewhere in the 200 volt range is where I wanted it to be. Considering the gain and the drive and everything I needed, I want to see somewhere around 200 volts on these plates. Okay, now I biased them different, so they're going to be a little different than 200, one from the other. But think of 200 as a target voltage, plus or minus 20 volts, okay? And that's what you're going to want to see. Now, I had a wild, overpowered power supply here. I'm putting out 400 and, almost 500 volts here, which is insane. So, I had to have mine, my resistor, dropping resistor is about a 100K. Yours, if you use the right transformer, is going to be, anywhere from 22 to 47K probably, somewhere around there, just depending. And you may have to experiment a little bit with it. Okay. Now I will tell you, you can use the voltage dividers and the resistance to the tube and everything, and you can calculate the current drop and voltage drop on these, and then figure out from that what this should be, making a voltage divider. But what you'll find out is when you do the math, it never works out the way you calculate it. You can get close, but you're still going to have to tweak it. Okay. So take my word for it, you're going to be somewhere, anywhere from 22 to 47K or a little more maybe. All right. Now, preamp. As you can see, this is a pretty traditional layout of a circuit, okay? We come in, you go through a 68K grid stopper resistor here, and we have a 1 meg leak resistor that it's really not grid leak, but we call it that. And I have a shorting plug so that when you pull the plug out of there, it shorts this to ground and shorts your output. And basically you have this 68K in here, so you're not dead shorting that. And you're basically causing the amp to be quiet when you don't have something plugged into it. If you notice the bias, now this is This is similar to what you would see maybe in like a Marshall type amplifier. Fender uses 1.5K and 100K. For 100K for the plate, 1.5 for the cathode. Marshall likes to raise that up to about a 2.7, and then we bypass it with a 1 microfarad capacitor. And what I found is that kind of gives me the gain right in the range that I want. Again, you can experiment with this. Remember, if you change this value and you reduce the overall resistance, the overall current flow through the tube is going to increase. Also, your gain, your biasing, everything changes with that. But what I'm trying to say is it's okay to experiment with this as long as you don't exceed the current limit of the 12AX7. So this can be anywhere from 800 ohms, 1K, somewhere around there, up to this range, and experiment. It's all about what sound you like. Okay, how the amp's going to start to break up, with distortion. All those different things are affected by how you bias this circuit. Okay. And I like this. If you notice, this is directly fed, so there's no volume here. So this is always running when the guitar is plugged in. Your volume comes after that. So if you want to set this for distortion by driving this with double coil pickups real hot, this will put out that type of clipped circuit or clipped signal, and then your volume control is right here. I used a 1 meg for volume control. I also used a 1 meg here in series with a 4.7 nanofarad, and for you microfarad folks, 0.0047 microfarads. Again, and a 0.1 decoupling or coupling capacitor. Now, the reason I used 4.7 nanofarad is I liked the sound. I liked the area that it started cutting off the frequency. This makes a very distinct change in the tone when you adjust it. So I really liked it. So that's why I used it. Again, by changing this value, you change the frequency at which this starts rolling off, on the highs. That's pretty much what this tone control does. All right. So we feed out of that. We go directly into the second stage of the 12AX7. And again, we're biasing this one a little more traditional. I biased this one like a Fender amp with a 1.5K, and then I bypassed it with a 22 microfarad 50 volt capacitor. Now, with this whole combination, I'm really driving this tube pretty hard, and I'm getting lots of gain. Although I was surprised it's not as noisy as you might think. You get some buzz. You're going to get some buzz off the strings and off the guitar. I mean, that's just the nature of the beast, unless you have, a noise gate pedal or something on the front end. But anyhow, we're feeding into this output tube, and this is where things get a little bit strange. This is a KT88 slash KT88 6550 KT100. Okay, and you could really, the way I have this biased, you could probably pull this out and just directly swap in a 6L6, and the 6L6 would, just because of its plate properties and everything, it would bias itself almost perfectly. The only problem is I'm running too high of a B+. Now, if you use this transformer, 300-0300, you have the luxury of, if you put a KT88 in here, it'll bias up a little bit hotter and you'll get a higher output. If you plug in a 6L6, you'll get it'll bias it a little bit cooler, and the amp will have a little lower power output, and plus it will affect the sound a little bit. Now, the other unique thing is I used since I had to order a transformer anyways, and since the price was really good from Edcore, I used an Edcore. I went ahead and put a transformer with a screen tap. So it's kind of unique. This is a single-ended transformer, but it actually has a screen tap on it. So it actually works really well. I tried it. I was really surprised. I was gonna I mean, I figured if I didn't need it, I could just disconnect here and just tie a, a dropping resistor here and come down to here with it, or go up to here with it. Can go run it in triode mode or whatever I wanted to do. But as it turns out, with this screen tap, it's kind of like an ultralinear type mode. Even though I'm not using feedback or anything, it worked out really well. Here's another issue with my power supply. By putting this 470 ohm cathode bias and having the 400/0400, this thing's running pretty hot for a KT88. If you have a nice, good quality tube, it won't red. It's not red plating. I'm not having any problems like that, but it is dissipating a lot of energy. This thing is running pretty much close to the maximum you would ever want to run it. It's not exceeding the ratings of the tube, but it sure is pushing it hard. This thing is idling at about 40 watts, 36 to 40 watts, about 36 watts. That's pretty hot for a KT88. Now, remember, there are amplifiers out there that are push-pull KT88s, and they're getting 100 watts RMS into 8 ohms with those one pair of KT88s. Again, you have to have the ones that can handle that. A KT100 is kind of a beefed up KT88. Also, a KT90 would be another one. Those are just a little hotter version. They all run at can run up in the 600 volt range for plate voltage, so my 500 volts really isn't giving me too much trouble. And I would even argue some of the old style, real high-end 6L6GC tubes, like the old GE or so forth, could probably handle that voltage as well and would bias up really nice, and they'd sit and idle probably at about 25 watts or so. That being said, my output to the speaker, I measured 18 watts. Now that's just feeding a signal into the input. That's not with a guitar. I would argue that this is probably a little bit higher than 18 watts when you're using the guitar with peaks and so forth. When you hear this, it's loud. For a one-tube amplifier like that with a single-ended little transformer, it rips. And this is a 25 watt rated transformer, but you got to understand Edcore and some of the other ones, like Hammond, when they rate their transformers, the lower end transformers, they rate them higher than you're really going to get. It's when they call it a 25 watt transformer, you're really going to get a clean maybe 18 watts or so. If you push it clear up to 25 watts, it'll do it. It won't, but the transformer will saturate and you'll start getting distortion. All the better for a guitar. So this is a 25 watt transformer, and I bet you I'm getting pretty close to that out of this thing. So that gives you a little idea. I'll try to scan this and put it up on the screen for a minute for a screenshot if you guys want to see it. We'll take care of that. And then let's flip this up and look inside. Okay, so I'm going to zoom you in, and we're going to start at the, I have this amp flipped on its side right now. We'll start at the bottom here, or on the left side of the amp, and work our way up. So first down here you'll see my power transformer, and it's just very typical. It just has the 6.3 filaments with the grounding tap. It has your AC input. It has your filament, 5 volt filament for the rectifier tube, and then it has your actual high voltage taps right there. There's your center tap and your plus 400, minus 400, or 400, 0, 400. If you look over here, I just made up a little circuit board. Very simple. I did the basic, use black electrical tape and, Sharpie marker to make my tracks. Etched it. Worked out really well. Here's your two 47s with your dropping resistor, or with your equalizing resistors. Then it goes up through these wires here into If you look there, right there's your 100 ohm, and I did a chassis mount. If you do these chassis mounts, you can buy them online. There's a lot of places, most electronics stores sell them. This little tiny resistor here is rated for 15 watts, and it has good heat dissipation because it's chassis mounted. So that's your pi network. Drops your little bit of voltage across it, and then goes into your next set of capacitors. Now here's the thing you guys have to remember. When you use capacitors in series, okay, it cuts your capacitance in half, but it doubles the voltage. That's why we do this. Now you have to put these resistors in here so that it will equalize any differences between the two capacitors, or one might exceed its rating while the other is not. The other thing you have to remember is the tops of these cans here are the ground. They're actually part of the capacitor. If you have this plugged in and running, and you touch between here and between here, and you look on this schematic, you are actually getting between here and here. So you're reading right across this bottom capacitor if you touch those two tops of the cans. You see what I mean? There's the top of the one can, there's the top of the other can. So if there's 500 volts on here, there's 250 between these two cans. Keep that in mind. Don't touch this while it's on. Okay? Anytime you do any of this stuff, know what you're doing, know how to work with electronics, and you're doing this at your own risk. If you work with it, be careful, work safe. Always unplug everything all the time. When you're poking around, plug needs to be out. Build my little stinger cable that I showed you on the stereo amplifier series I did. Make one of these. Did go around and discharge everything. Make sure you do it. Okay? Every time. We come out of this here, and we have our main red wire, and that goes up, and that feeds the input to the output transformer. Then it also goes to this other dropping resistor. Now here's your 100K, and this is rated at 2 watts, and it just barely gets lukewarm. And then there's your other filter capacitor for that. That in turn comes out of the blue wire and goes up to what we're going to look at, our preamp section here. For the preamp, you can see here, comes in up here, goes to your plate resistors. There they are here, and those are 100K. Okay, so let's put a little bit of light on the subject. All right. So we have our 100Ks. And these come off of your blue wire. You have your ground here. Here is your 68K coming out of the shorting type our phono plug. Then that goes into pin 2. Then you have your, actually I'm using these, I have these reversed from how I have them on the schematic because it was just more convenient this way. It doesn't matter which end you use in there. So here's your cathode bias resistor, the 2.7K and the 1 microfarad capacitor going to ground. These are all grounds. Then you have your coupling capacitor, the 0.1, and that's going to here, which in turn goes through your volume circuit. So if we look down here, here's your volume circuit. And let me take you out so I can show you a little more closely. So there's your volume circuit. Comes into the volume. That goes down to your tone capacitor. And your tone capacitor is right here, then goes up to ground. So here's your grounds, this black wire. Here's your tone capacitor coming off of the input of the volume pot. Then you come out of the wiper of the pot, and then it goes back up. And let's get back on the stand so I don't give you vertigo. Okay. And it goes right up to here, to the next stage of the tube. And then we come out of there and go to this shielded wire. I actually used a shielded wire. And then there's your cathode and your bypass capacitor right there for that one. And you can see it's a 1.5K, just like the fender. Comes down and goes into our input of our KT88. So here's your decoupling capacitor for that one, and it goes into pin 3, and then we have that have like a little leak resistor here, and that's a 470K. Alright, which actually I just noticed, guys, look at that, it's a 47K. I need to take that out. That got mixed in my bin with the 470Ks and I didn't even catch it. So we're gonna have to fix that. That's too much on that, so we're gonna have to change that. But we'll do that here when we're done. Still sounds good with this, but it really needs, this will open it up quite a bit. Then right here is your cathode bias resistor. It gets hot, it'll get warm, not hot, but it'll get warm. So it's a chassis mount also, 15 watt, 470 ohm. And then here's your 10 microfarad bypass capacitor for the cathode. And then right here is your output transformer with your screen tap in the middle. And you can see it's going over to pin 4. Screen. Okay. So everything's good. And this, I'm sorry, this was pin 5. Pin 3 is your plate. I'm going off the top of my head here. And then down below it you see your 5U4, which is very simple. You just have your filaments and your plus output, and then your 2 inputs from your power transformer. That's all there is. Comes out of the transformer, goes up to a couple of banana jacks that I have, and that's the amp. There it is. That's the nickel Tor. So what we're going to do is, the first thing I'm going to do is I'm going to fix this problem and put the proper 470K bypass, and then I will be back and we will listen to some of the worst guitar playing you've ever heard. What can I say, guys? You know, can't do everything, can we? Alright, so let's get that done and we'll be back. Okay, just to give you an idea here, this is the guitar I built. You can see out of a piece, I used some ash that I picked up at a Amish lumber yard, and then, believe it or not, the fretboard is made out of a Brazilian hardwood called Padauk. I don't know if you've ever heard of that before. P-A-D-A-U-K. You can see that all the way up to the maple headstock, and the neck itself is maple, and I did the skunk stripe on this one, as you can see. Not bad. I mean, you know, fret job is decent. I hand cut the frets. I hand carved the neck. This was one of my first ones, and it was a prototype, and it plays. It's the intonation is okay on it and everything. But hey, I'm not a luthier by any stretch of the imagination, but I thought I'd show you that and let you see what it is you're going to be hearing. If I swing you around this way, here's the amp, and it's turned on. I don't know if you can hear that little tiny bit of hum. I'll point towards the speaker. This is a speaker we're going to use. It's a 12-inch, and this is the one when we build the cabinet what we'll mount. Nothing special. Okay, I have the knobs upside down right now, so that's why they're kind of out of whack. You can hear. I'm not even plugged in. I have this plugged in, the wire's hanging open, and you could hear. It's a pretty quiet amp. So let's plug it in. I don't have a pick down here. I can't find one. I have picks in my Fender Stratocaster case, but I really don't want to get it out. I also have a Fender. But, and for all of you guitar collectors, I have a vintage G&L Skyhawk made by G&L. It's beautiful. Has the tilt neck with the 3-point mounting. Any of you that have ever heard of those, they're really amazing. When I got the guitar, it was hardly ever played, but whoever bought it destroyed it by, they filed the frets down for some reason, and it's ruined. You can't tune it. It needs a fret job. And it's so valuable and so collectible of a guitar, I don't want to try it yet. And it's got a fully lacquered neck where they lacquered over the frets and everything when they made it. It's a really hard fret job to do. But anyhow, enough about that. Let's listen to this thing. Let me get it plugged in and I'll be right with you. Alright, let's strum a chord here with my fingernails that are cut real short. As you can tell, it is really loud. So you can hear and I don't have it cranked all the way up. It's just too loud. So without a pick and without practicing, that's all you're going to get out of me, guys. But you can hear that, you know, the low notes and the high notes. Now, if we listen to the tone, hear that? So, tone cuts right where you want it. So, maybe we'll get somebody over here that knows what they're doing. I have a lot of friends that are good guitar players, better than me. I'm more of a bass player. If we ever do a bass amp, which I may do a video on that, I can do a little better on that. But that gives you an idea of how this thing works. Next part probably, if there is another part to this video, it'll just be mounting it up in a cabinet. I'm going to make up a cabinet out of plywood down in the shop, and I think this thing's going to be ready to go. So again, that's it. I'm going to end this video with putting a capture of the schematic on there, and forgive my scribbly handwriting and everything, but hopefully you can make it out. Again, if you have any questions, feel free to to comment down in the comments section or to message me. And as always, if you like this video, give me a big thumbs up, and hopefully next project we do won't be fraught with so many problems. All I could say is that was just it was a pretty crazy start to a video series, but I think we redeemed ourselves here. And next thing is, let's hear this thing mounted up in a cabinet. Lots of other projects coming up. I have that Pioneer SX 1050 that I need to do. I have some customers that's going to be sending me in a few things that I have to get done. So maybe we'll get some more X-ray video in there. I'm not sure. And so lots more. I'd like to do some more radio things. And I'd also like to show you my new bench here. I really didn't share that with you on this particular video, but I made some pretty major renovations to the bench, and we'll do that later as well. So again, thumbs up, and more to come later. Have a great day.